Okay, so last week you ended the week by doing some vocabulary for circles. So first I'm going to do a quick review of what some of those things were. So first of all, you have circle. This would be circle B. Circles are named by their center. The circle has a couple of radii here. Radii is plural for radius. You have radius AB, you have radius BC. Now, if a chord is just a segment on the circle, went through the center, it would be a diameter. A diameter is twice a radii. And then we're going to go on to a few different things. So you have a central angle of a circle. A central angle would be like angle ABC. A central angle is when the vertex is on the circle. Okay. Now, right here you have the definition of a degree. A degree is 1/360th of a circular rotation about a point. Now, because of that, that's going to lead to something that we're going to talk about in a second. Now, let's talk about arcs. So we have a minor arc. An arc is a piece of a circle. So any piece of a circle. So we're going to talk about, first of all, we have like a minor arc. A minor arc would be like AC. Okay. So minor arc AC is going to measure less than 180 degrees. Okay, and it's going to be named with two letters. Now you could have a major arc. A major arc would be something like ADC. So ADC would go like all the way over here. So ADC would be an example of a major arc. You can kind of see I've got the little arc symbol there. So ADC would be an example of a major arc. That's going to measure more than 180 degrees, and you're normally going to use three letters to name it because you don't want to be confused. If I just said AC, you're going to go that shorter distance. So I needed those three letters to know which direction to go in. And then the last thing we're going to talk about is a semicircle. You probably have heard of a semicircle before. Semi means like that half. So a semicircle actually equals 180 degrees. A whole circle, a complete circle, is 360 degrees. Half of that would be 180. It's going to be formed if we had a diameter. So if I was to kind of draw this straight across and maybe make this E. So maybe ABE would be a semicircle. You could also say AE for that. A semicircle could be three or two letters, it doesn't matter. Now back to that definition. Because of the circular rotation and the definition of a degree, and that's kind of some fancy definition, but mainly what you need to take from that is if I have a central angle, again the central angle being any angle whose vertex is on the center of the circle, is always going to have the same measure as the arc it intersects. So if this was 120 degrees, this arc here would be 120 degrees. If this was 60, this would be 60. This semicircle here, this is a straight angle, as you can tell. Thus, that semicircle is 180 degrees. Okay, so you can kind of see down here, that's coming into play. We have a complete circle is 360 degrees. Therefore, these three angles have to add up to 360 degrees. So again, we're going to use that principle to find the measure of some angles and then thus find the measure of some arcs. So for this first example, it asks us to find angle X and then the measure of arc AD. Okay, so we're going to find, sorry, that's a typo there. It wants a mark of C. Arc CD. Sorry, let's fix that. Arc CD. So let's find those two things. So first of all, let's find CD because that shouldn't be too bad. So you have CD, right? So CD, this here, and this angle should have the same measure. So to do the measure of CD, if this angle here, CAD, measured 85 degrees, that arc should be the same measure. Okay? The central angle and the arc have the same measure. Now, as far as to find this angle, we know circles add up to 360 degrees. So to find X, pretty much, remember that box means 90 degrees, I'm just going to take 360 degrees and subtract those values. So I'm going to take 360 minus 85 minus 40 minus 90 and get the answer. Now some of you are very happy right now that you're not in class, so you don't have to write down that work. You can just type in the answer. But again, this is not necessarily one you would need to show a lot of work for. So I went ahead and put that in my calculator. I'm double checking the math and getting 145 degrees. So 360 minus 85 minus 40 minus 90. Again, if I was taking a quiz, I would add all those up. The 145, the 85, the 40, and the 90. Those should equal 360. Again, all these angles need to add up to 360, and all those arcs did. So 145, so if they asked for DE, that would also equal 145. Now going over here, I have the same issue. This angle, and that angle have to equal 360, because right here the complete circle equals 360. So to get an X, say 360 minus 130 minus 90. Subtract those values. Whether or not you use a calculator is up to you. Okay, for that one I'm getting 140. So X is 140. Now they did it in this case, but if they asked for arc GJ, that would also be 140. Okay, now for this one right here, it told me that AC is the diameter, so that means it's going to cut it into two semicircles, which measure 180 degrees. Okay, diameter, semicircle, semicircle. Now what it's asking us to do is classify each arc measure and then find its measure. Now normally what I like to do is classify these as major arcs, minor arcs, semicircles first, because that's going to help me know whether or not my angle measures are correct. So first of all, DAB all the way around. So go ahead, I've got DAB. I'm looking at that. That's way more than half the circle. So I know that DAB, that's going to be a major arc. So I'm just going to write major arc in here. Major arc. So that's my first one. Now whereas DC, if I look at DC, that's definitely less than 180, less than half. So by definition, that's a minor arc. Now my last one, they did ABC. So for my last one, I'm looking at that. So they did ABC. So ABC, well, ABC is half the circle. So ABC, half the circle, that is definitely a semicircle. So since I know that's a semicircle, for that one right there, I'm going to go ahead and put that's 180 degrees. A semicircle, that's done. No math needs to be done for that one. So now going back to the other ones, I need to figure out measurements. So I'm going to go and I'm going to figure out what I know. If this is 90 and this is a semicircle, right next to this also has to be 90. So I could put it in the little box if I want. So if that's 90, this is 90. So for here, I know this is going to be 90 degrees. Okay, it's because you've got a straight line. This is kind of like the straight angle thing. So to get this, I did 90, 90, so 180 minus 90. So to get this, that was 180 minus 90 equals 90, for those of you who need that. Now right here, I have another semicircle thing. Okay, so that may come into play because I need to know what this little region is. So to get this little region, I'm going to take 180 minus 47. Okay, so 180 minus 47. So I know that from here to here, from this to that is 133. Now, the reason I need to know that is it's asking me to find DAB. So I want to get from here all the way down from here. So from this down to this. So to get that, to get DAB, I'm going to take this 133 And I'm going to take that 90 and I'm going to add them. 133 plus 90, and that's going to give me that major arc there. I'm going to add in those two things. So that one's going to be 223. I had that answer there. So those are the ones I used. I use this, I use this, I used my 90. I did not need those. That 133 was a trick. They didn't ask me for that one. So now the last thing we're going to talk about is circle graphs. Now you probably have seen graphs like this before. Okay, circle graphs, pie charts, you've read these in classes. Now we know that circles are 360 degrees. Now just so you know, they get these percentages. They don't make up how big each of these is. To get the size of this, they take 27% of 360 to decide how big that arc is. So they want to know how big arc JK is. So that's 21%. So for you to find that measure, you're going to change the percent to the decimal. So the first step is change the percent to the decimal. So I'm going to take 21% and just move that. So that's 0.21. Okay. And then you're going to multiply by 360. So to get the measure, let me move that up, sorry. To get the measure of JK, I'm just going to take that 0.21 times 360, and that's going to tell me how many degrees are in JK. So I'm getting 75.6. Had they asked for the measure of JQ, you would have taken 0.27 times JK. Now for this last one for arcs, they want you to find WY. So to find the measure of WY, well, I know this is 90, I know this is 62. So to get the measure of WY, just remember this box is 90. I'm just going to take 90 plus 62. So the measure of that is 152 degrees.